Ideation. Let me guide you through an example of the design thinking process using Litka's 4 stages. What is? Over recent decades, we have formed a society dependent on disposable plastic products. Plastic has a wonderful array of properties that have made it ideal for countless applications and purposes. However, the rate at which we are demanding these items is growing rapidly and unsustainably. What has gone most unnoticed is the problem of disposing plastic waste. Researchers estimate that only 30% of all plastic ever produced is now in use. However, every single piece of plastic ever made still exists, because of the material's resistance to break down naturally. We use plastic to our benefit. However, there is a huge environmental cost to this. Humans are conducting an uncontrolled experiment on a global scale, in which billions of tons of material will accumulate across the fragile terrestrial and aquatic ecosystems on the planet. Not only do the toxins in plastic affect the ocean, but acting like sponges, they soak up other toxins from outside sources before entering the ocean. These chemicals are ingested by animals in the ocean. That is not good for humans. The problem. What if? A company based in New Zealand called Biofusion is attempting to address the global plastic waste problem by providing a permanent purpose for the material. The company invented a portable machine that turns plastic into bricks. Scientists have come up with a new way to turn plastic waste into liquid fuel, as they believe that plastic is considerably higher in energy than coal or wood. A company in Ghana called Nelplas Ghana Limited is behind a breakthrough innovation of providing plastic a permanent purpose. They are turning plastic garbage into stone-like pavement blocks, which can be used to build new roads and even roof tiles. What if we can use plastic waste to produce wind turbines in order to charge power? What if we can even make cars out of plastic? Better yet, what if we can use plastic as the primary material to make almost anything imaginable with the use of 3D printing technology? What wows! Firstly, recycled plastic is collected and taken to a facility where the plastic is shredded and granulized. These plastic granules are then melted and turned into filaments by a filament extruder that makes it possible to be used in a 3D printer. I will be using 2 common plastic mesh bags. These bags will be taking the place of steel reinforcements in this experiment. First, I cut them according to the mold size. Then I combined the concrete premix with the water according to the product's specific instructions. Next, I layered the plastic mesh sheets into the mold, pouring the concrete after every 2 sheets. After I leveled the mold, it was left to dry. The prototype turned out to be both successful and unsuccessful. Successful in the way it binds with the concrete, but unsuccessful as it needs to be more leveled when it is made into the mold. The plastic is very light and reacts differently with different concrete consistencies. It can, however, aid in building insulation onto foundations to potentially lessen the need for underfloor heating.
What works? The solution.
The pestle analysis will now be explored to zoom into the possibilities and constraints of the implementation of this solution. Carbon taxes and recycling legislations and government strategies would influence the implementation of this solution. Labor, transport, and technology costs will certainly constrain the scale and methods of the solution. Social influences would need to be considered to impact society's recycling behaviors. The sorting, shredding, and filamentation process are influenced by the development of such technologies, especially the 3D printer's size, speed, and accuracy. The environmental impacts of the solution process, as well as the manufacturing process of the 3D printers, are influencing factors of making the process as sustainable as possible. Legally, the process will be impacted by waste protocols as well as facility permissions and restrictions.